In this video, we're going to walk through the setup of the Electric Solutions Lab, which is also labeled experiment number 14 on your lab sheet. And we're going to be doing this considerably differently than the procedure calls for, because the procedure calls for a macro scale lab, which means you use beakers, or in this case it calls for cups or flasks, and you use large amounts of chemicals. When you do that, instead we're going to do it micro scale, which means you use a cell plate, as such as pictured here. You use smaller amounts of chemicals. Because of that, there's less waste, you use less chemicals, and it's also safer because you won't have large amounts of chemicals to worry about spilling. These are the materials for this lab. You'll find them on your lab table for the most part, your cell plates in your drawer. We will be using toothpicks to stir each of the individual cells, so toothpicks will be provided to you to do that. Those will not be in your lab drawer. So from your drawer, you're going to get out your cell plate, and I'm looking at the procedure part 1. It says to half fill 6 beakers or cups. We're going to fill up 6 of the cells of your cell plate with the distilled water that you find on your table. And then you're going to take a very small amount, so here I show a scoop with one of the chemicals, a very small amount of the chemical, and you're going to put that into one of the cells and use your toothpick to stir it up. And so you're going to do that for, as it shows in procedure step number 2, the 6 different cells. Now it calls for, in cup 5 and 6, 10 milliliters of hydrochloric acid, and cup 6, 10 milliliters of vinegar. So what you can do with that is just put several drops into the cell so that the cell has enough liquid in it that you can test it. So next we're going to go and look at the tester. Now the procedure again calls for an older kind of conductivity tester. So we have an electronic conductivity tester, which has on it, down in the lower and left-hand corner, the 2 electrodes that you're going to place into the solution, and in the upper right-hand corner are 2 LEDs, a red and a green LED, that are going to light up and tell you about the conductivity of the solution. So here is the key for what the different colors mean. It's on the back of the conductivity tester, so you just need to turn that over and read it, and you can see that we can go from a low or no conductivity up to a very high conductivity based on what colors we get from the LEDs. So here I am testing a solution that I made in one of the cells, and you can see that the red light is very bright and the green light is somewhat medium, indicating that this is a very high conductivity solution. And we should ask ourselves throughout this lab, what does it mean that we have a high conductivity of a solution? Now, after you've done each of the different cells and tested them, you need to rinse off the chemicals, the chemical solutions from the electrodes. And so here I am using the distilled water bottle to rinse them off into a beaker. You can just rinse them off into the sink. But make sure you do that between each different test. Now, once you've tested them all, on procedure step 4, it says for the ones that cause the bulb to light, pour a small amount. So what we're going to do is take an eyedropper and take some of the solution that we prepared before, and just take a drop or 2 of that and transfer it to another cell, as shown here, and then use the distilled water to fill it up. So basically what we're doing here is we're just diluting the solution that we had originally made in another cell so that we can test it. And so here I am testing the second solution, and this time, although the lighting situation is a little different, you can see that the red LED is lit, and the green one did not light, so that indicates to us that there is less conductivity in this one. Now once again, you're going to need to rinse off your conductivity tester between each of the different solutions. So make sure that you're recording for each of the solutions, and keep track of which solutions are which, of course, but record for each solution what its conductivity is, and so then you can use the conductivity information to determine some of the properties of the solutions.